Imagine a quiet morning unfolding at your kitchen table. The sun streams in, casting a warm glow on your coffee cup. The day stretches ahead, full of promise and undisturbed peace. Suddenly that tranquility shatters as the floor begins to tremble, ever so slightly at first, then escalating into a deep guttural roar. Pictures rattle violently against the wall, their frames knocking and clattering. Glasses clink precariously on the shelves, threatening to topple and shatter. And outside, the very ground beneath your feet sways violently, as if a giant hand is shaking the earth. This is the raw, untamed power of an earthquake, a force of nature that can reshape landscapes in an instant. It's a power capable of flattening entire cities in mere minutes, leaving behind a trail of devastation and despair. For centuries, humanity has strived to understand and outsmart these unpredictable disasters, learning from each devastating event. Stronger buildings, designed to withstand the tremors, and well-rehearsed emergency plans offer a degree of protection, but these measures only react after the quake hits, offering little solace in those terrifying initial moments. What if we could pierce the veil of uncertainty and know an earthquake was coming, not just seconds, but hours or even days in advance, giving us a crucial window of opportunity? That would mean precious time to evacuate vulnerable areas, to secure hospitals, ensuring the safety of patients and medical staff alike, and to proactively prevent fires, a common and devastating consequence of earthquakes. This isn't some far-fetched science fiction dream. Dedicated scientists are working tirelessly on this very problem right now, pushing the boundaries of what's possible. The key to unlocking this predictive power may lie in the tiniest building blocks of nature, the realm of quantum mechanics. We know that earthquakes predominantly strike along fault zones, those fracture lines in the Earth's crust. These are the areas where massive tectonic plates grind together, building up immense pressure over time. We can meticulously measure the stress building up within these zones, but we still can't pinpoint the exact moment when that stress will finally overcome the friction and cause the fault to snap. Traditional seismometers, while invaluable, only give us seconds of warning. That's after the quake has already started, when the destructive waves are already radiating outwards. To truly predict earthquakes before the first tremor is felt, we need a fundamentally new kind of tool, one that can detect subtle precursors undetectable by conventional methods. Enter quantum mechanics, a field that explores the bizarre and counterintuitive world of atoms and subatomic particles. It's the science of the ultra-small, where the rules of classical physics break down and new possibilities emerge. Sometimes the biggest breakthroughs, the ones that truly change the world, come from the most unexpected places and disciplines. Let's explore how the seemingly esoteric world of quantum science could revolutionize earthquake warnings and save countless lives. Predicting earthquakes has always felt like an insurmountable challenge, a puzzle that has eluded scientists for generations. The Earth holds its secrets deep within, and unlocking them to forecast these devastating events has seemed, until now, an impossible task. It's been like trying to guess when and where lightning will strike, a game of chance against the raw power of nature. The unpredictability has been the defining characteristic. Traditional seismometers are invaluable tools, but they only give us a few precious seconds to react once the earthquake has already begun. To get a real, meaningful warning, a head start against the impending disaster, we need to detect the subtle signals, the precursors, before the ground begins to violently move beneath our feet. Scientists now believe that stressed rocks deep underground under immense pressure emit faint, almost imperceptible magnetic changes as they approach their breaking point. The challenge is that these signals are incredibly subtle and weak, like trying to hear a single whisper in the roar of a crowded stadium. But now, quantum technology is giving us super hearing, the ability to detect these faint whispers amidst the noise. Quantum sensors, with their unparalleled sensitivity, can pick up the tiniest magnetic shifts that are completely invisible to regular conventional technology. Instead of passively waiting for disaster to strike and then reacting, we can actively listen for these early warning signs, giving us a crucial advantage. Researchers around the world are diligently building and refining these quantum sensors that measure even the smallest magnetic changes with unprecedented precision and accuracy. It's a remarkable fusion of geology, physics, and cutting-edge engineering, opening a new frontier in our ability to understand and predict earthquakes. By harnessing the incredible power of quantum mechanics, we're learning to listen to the Earth's subtle rumblings in a whole new and profound way, and what we hear, with these revolutionary sensors, could ultimately save millions of lives in earthquake-prone regions around the world. Diamonds, traditionally symbols of luxury and beauty, aren't just for jewelry anymore. For centuries, they've adorned royalty and been cherished as precious gems. But now, these remarkable crystals are stepping out of the jewelry box and into the laboratory because they're becoming powerful scientific tools, poised to revolutionize fields from medicine to geology. The secret to their newfound utility? It lies in tiny imperfections, specifically atomic-level defects called nitrogen vacancy (NV) centers. These aren't flaws that diminish the diamond's value. Instead, they unlock its potential. These atomic-level flaws act like ultra-sensitive quantum compasses, capable of detecting the faintest magnetic fields with incredible precision. The NV center's spin, a quantum mechanical property, changes in response to magnetic fields, acting as a tiny sensor. It can detect even the faintest ones, signals that would be undetectable by conventional sensors. Scientists use lasers to read these changes in the NV center's spin state. When illuminated, the diamond glows red, revealing the magnetic field's secrets encoded within the light. Unlike other quantum devices that require supercooled temperatures, diamond sensors work at room temperature, making them far more practical for real-world applications. That means they're small and easily integrated into existing technologies. They are also durable, able to withstand harsh conditions, and relatively affordable compared to other quantum sensing technologies. Imagine the possibilities. We can deploy networks of these sensors right where earthquakes strike, providing unprecedented insight into the Earth's movements. Each diamond listens for magnetic whispers from stressed rocks deep beneath the surface, detecting subtle changes that could indicate an impending quake. Together they form a web of early warning, potentially giving us precious time to prepare and save lives. This technology represents a remarkable transformation, turning a gemstone's flaw into a life-saving advantage. The future of earthquake prediction, and potentially many other scientific fields, could be hidden in a handful of diamonds waiting to be unlocked. One sensor isn't enough. Earth's magnetic field is full of noise. Solar storms, lightning, even trains can create false signals. That's why scientists use networks of quantum sensors along fault lines. Each sensor streams data to a central computer. AI algorithms sift through the noise, searching for unique local patterns. If several sensors detect a slow-growing magnetic change, the system raises an alert. At first, experts review the data. If the signal strengthens, a public warning could follow. This approach turns faint, confusing whispers into clear, actionable alarms. It's a blend of quantum sensing and artificial intelligence. The result? A smarter, faster earthquake warning system. This isn't just theory. It's happening now on the San Andreas fault. Scientists are installing quantum diamond sensors alongside traditional instruments. They're building a library of magnetic fingerprints from real earthquakes. By comparing data, they're learning to spot the warning signs before a quake. Field tests reveal practical challenges and refine the technology. Every new data point brings us closer to a global, reliable warning network. Imagine cities getting hours of warning before a major quake. Lives could be saved, people evacuated, emergency crews ready, infrastructure protected. Automated systems could shut off gas, water, and power to prevent secondary disasters. The economic and recovery benefits would be enormous. Quantum diamond sensors are small, robust, and affordable, ideal for global deployment. Even developing nations could build dense sensor networks. Shared data would create a worldwide map of tectonic stress. For the first time, we could anticipate earthquakes, not just endure them. This isn't about controlling nature, but understanding it, and living safer lives. The future of earthquake safety is within reach. We've journeyed from shaking cities to quantum diamonds. Science is about curiosity, asking big questions and finding creative answers. The story of quantum sensors is still unfolding, and you can be part of it. Stay curious. Ask questions. Explore the world around you. Learn, share, and inspire others with what you discover. Science isn't just for labs, it's for everyone. By spreading knowledge, you help build a safer, smarter future. Now go out and start exploring.